So Arduino launched two new boards that are made in India, and these boards are the Arduino UNO R4 Minima board and Arduino UNO R4 Wi-Fi board. But do you know the reason why Arduino started manufacturing in India? Well, let me explain. So as per the report, India is the largest market for Arduino IDE downloads, and based on this number, there should be a significant number of original Arduino boards to be utilized, but the reality is totally different. Again, as per the data from the global Arduino distributors, Indian customers are not even 1% of it, as the total Arduino boards market is captured by the clone version due to one very simple reason, that is pricing. Here on the screen you can clearly see the price difference between the original Arduino board and the clone version of it. It's a huge difference, right? And now to fix this issue, Arduino planned to start manufacturing the Arduino boards here in India, which will significantly reduce the price of the original Arduino boards, and that was the reason Arduino started manufacturing here in India, and we already got two products from them. So now let's first have a look over the quick unboxing of both the products. So first let's start with unboxing Minima board. So inside it we get to see a couple of paperworks from Arduino and the main board itself, which has the UNO R4 Minima branding on the top and made in India written on the back. Well, here I was expecting some Arduino stickers with Indian touch, but we do not have any stickers inside it. Anyways, let's open another board, and this also got same paperworks and the main board inside the box, which also has the UNO R4 Wi-Fi board branding and made in India on the back. And that's all about the unboxing experience. And now let's have a look over the specification of this board. So for the specifications, let's compare the new UNO version with the previous revision UNO R3, and let's see what are the major upgrades in the new version. Talking about the microcontroller, then previously it uses the Atmega 328 chipset, which is an 8-bit microcontroller, and while in the newer version we got Renesas RA4 M1 chipset, which is based on ARM Cortex M4, and it is a 32-bit microcontroller, so we can clearly see the difference here. So the new version will be definitely way more faster and powerful than the previous one. Talking about the USB connectivity, then it was USB type B previously, the one which we used to see in our printers, while in the newer version we have the common and most versatile USB type C connector. Talking about the pins, then pins are more or less the same. It's just because they want to maintain the same form factor as the previous UNO versions. Okay, so as you can see, the built-in LED pin is on 13, while it is not mentioned here, but I guess it will be 13 only. The digital pins were 14, and here as well the digital pins are 14. The analog pin and PWM pin were 6 respectively. Here as well analog pins are 6, while the PWM pins are 6 as well. And in addition with the PWM pins, the new version got a dedicated DAC, that's digital to analog converter. So we have one single pin for that, which was missing in the previous version. So this will be really helpful for all the audio related application where you need to generate an analog signal. Okay, later on talking about the communication protocols, then it got all the communication protocols that we were having previously, like UART, I2C, SPI. In addition to all three, we got an all new CAN bus protocol as well, and CAN bus protocol is commonly used in the automotive industry. So this new Arduino version got support for CAN bus protocol, and we can do some new projects with this. So I'll definitely try to make a dedicated video about how to use the CAN bus protocol and how does it work using the Arduino UNO board. Now talking about the power, then the new version is also the 5-volt board as compared to the previous version, but the input voltage range is significantly increased. So previously we can only provide from 7 to 12 volt input, but now we can provide up to 24 volt to power up the board. One major downgrade in the new version is the DC current per pin. So previously it was having a 20 milliamperes of current from each of the pin, while it is reduced to just 8 milliamperes per pin. So you need to be very careful while making project with this particular new version. It's also mentioned here on the top of the page, like the maximum current draw per pin is just 8 milliampere, and if you try to provide or source more current, it may damage your pin or the board itself. So you need to be careful in this particular thing. Later on talking about the clock speed, then previously it was just 16 megahertz, but now it is running at 48 megahertz. Definitely it will be much more faster. Now talking about the memory, then previous version got 2 KB of RAM, while here we have 32 KB of RAM. Previously we were having just 32 kilobyte of flash, but now we have 256 kilobyte of flash, and we got 1 KB of EEPROM previously, and EEPROM here it is not mentioned, but it is somewhere around 8 KB I guess. If I check the data sheet, it is mentioned here. As you can see, 8 KB of EEPROM is provided in the Renesas chipset, so it is ready for all your heavy programming as well. And talking about the dimensions, then it is exactly the same, because as I said previously, they tried to maintain the same form factor, same pinout as compared to the previous generation, so that you can use all the shields and add-ons onto the new Arduino board that you were using previously in the other Arduino boards. Well, there are definitely some of the features which is not mentioned here, the technical specifications, which are kind of a new features. So let me tell you. So this new board also got built-in real-time clock, so now no need to add external RTC, and it also supports HID. That means you can create mouse and keyboard based applications using the Arduino board itself, which was also missing in the previous generation. So these were all the technical specifications and the improvements that we get as compared to the previous generation. But now let's see what more or additional features does R4 Wi-Fi provide as compared to the R4 Minima. Let's have a look. Okay, so here on the right we have the UNO R4 Wi-Fi board, and on the left we have the UNO R4 Minima board. And the UNO Wi-Fi board got all the technical specifications that UNO R4 Minima has, plus it got some additional features, just like it got a radio module in it, which is ESP32S3 Mini 1-N8 chipset, with the help of which we can get the Bluetooth and Wi-Fi based connectivity. Additionally, this ESP32S3 chipset can run up to 240 megahertz, that we all know all the espressif based chipset are running on 240 megahertz. And one more thing which we need to take care is if we are using just the ESP32S3 from this UNO R4 Wi-Fi board, well, it works just on 3.3 volt logic, not on the 5 volt logic. So if you're using it directly, you need to be careful about it. While all the pins exposed onto the R4 Wi-Fi board are of 5 volt compatible, because it also got the Renesas RA4 M1 chipset. So basically the Renesas is the main controller in this, while the ESP32 is kind of a co-processor, you can say, and both are communicating via UART protocol. So when you program the board, the program will get uploaded into the Renesas chipset, and later Renesas will communicate with the ESP32 chipset via AT commands and stuff like that. Okay, and there are a couple of more things which are not mentioned here, but let me discuss it. So here we have the quick connector as well on the UNO R4 Wi-Fi board, which gives us an additional I2C port, a dedicated I2C port which works on the 3.3 volt only, and we can use it by calling wire1.begin. So we can add all the additional I2C based peripherals directly to the quick connector. That's an additional feature. Plus we also have this LED matrix, the 12x8 LED matrix on board, on which we can display anything that we want. So these are a couple of the additional features that UNO R4 Wi-Fi has as compared to the UNO R4 Minima. And with this, we have discussed all the important technical specifications of both the boards, and now let's move on to Arduino IDE and let's see how to use both the boards, and let's try to upload a couple of example codes. Okay, so here is my Arduino IDE, and I'm using the version 2.3.2 currently. And first of all, we'll see how to program the Minima board. Now here, as the board and the IDE are both from the same company, Arduino, we'll able to see the compatibility, like it will automatically detect which board is connected with the computer. The installation of boards will be super quick, and uploading compiling code will also be a lot faster as compared to the other boards like the espressif based boards. Okay, so now let me show you how to add the boards. For that, you need to simply go to boards manager, and here just search for UNO R4 and you will get this Arduino UNO R4 boards by Arduino itself. Just click the install button and you have successfully added the support of programming this board into this IDE. Okay, so the board is successfully installed, and I already connected my Minima board with the computer, and if I click on this, as you can see, it automatically recognized Arduino UNO R4 Minima board is connected with the computer. Now Arduino UNO R4 Minima and Arduino UNO R4 Minima both are the same hardware, so it is not showing here. Okay, so I'll select this, and now we are good to go to upload the sketch or the code inside the Arduino UNO board. So now let's take a look over the example codes provided here. So these are the dedicated example codes for Arduino UNO R4 Minima. And now here, rather than uploading the simple Blink example code, let's try to upload an example code that covers a unique feature of this board. For example, this board has HID in it, as I said, so let's try to upload the keyboard example code here. So I'll click on keyboard and serial. So what this example code will do is it will make our UNO board act like an USB keyboard, and whatever we type in the serial monitor, it will type the next letter of it. For example, if we type capital A, it will give us the response as capital B and so on. So here I don't think we need to do any changes at all. We'll just hit the upload button and test it out. Okay, so the code is successfully uploaded. Now I'll open the serial monitor and now we are good to go to test it out. So let's just try to type capital A here, and if I press enter, as you can see, the B is automatically returned by this UNO board, which is currently acting as a keyboard. Similarly, if I type 1 here, I'll get 2. Similarly, if I type a small s, it will type small t. Okay, so this is how you can make this UNO board act as an HID device, a keyboard and mouse, and you can make some unique projects out of it which were not possible in the previous UNO versions. And that's how you can upload your first sketch or any of the sketch into the Arduino UNO Minima board. And as mentioned on the website, this UNO board, which is based on the Renesas chipset, will still support all the sketches that were previously written for the ATmega 328, but you just need to be careful of one single thing, which is current per pin. As we already discussed, it can source only up to 8 milliampere, so that is something you have to take care. Otherwise, it will support all the previous codes. So now we are done with the Minima, and now let's disconnect the Minima board and connect the Wi-Fi board with it. And here in the Arduino, as you can see, it automatically recognized as UNO R4 Wi-Fi board. That's because of the compatibility. We can select it and now we can upload the code into the UNO R4 Wi-Fi as well. But before that, I really like the built-in example code of the UNO R4 Wi-Fi. Like, we get to see a beautiful animation on the LED matrix, and it ends up with the heart in the center. Looks really cool. Anyways, let's try to upload the example code in the UNO R4 Wi-Fi as well, and this time also I'll try to upload the example code that will test its unique features. So as this board got Wi-Fi built in, let's test out the Wi-Fi related example code. So we'll go to Wi-Fi S3 and let's click on AP Simple Web Server, and this will create an access point of this UNO R4 Wi-Fi board. We can connect to it and we can control the onboard LED, and we do have a similar kind of code for the ESP32 boards as well. So now what I'll do is I'll just hit the upload button and let's see how it works. Okay, so the code is successfully uploaded. I'll open the serial monitor and let's just press the reset button. Creating access point. Okay, it already created the access point. So now I'll connect my computer with this access point. Okay, and now I'll open up this URL in my browser. And as you can see, we got the big letters which says click here to turn the LED on and click here to turn the LED off. So it got a built-in orange LED as we have in all other Arduino boards. So what I'll do, I'll click here to turn it on first of all. And here, as you can see, the LED got turned on, the orange LED. And if I click here, the LED got turned off. And here on the serial monitor, we are also getting the response from the client. Okay, so it's the same kind of code that we used to do in the Espressif boards. And with this, we have tested its built-in Wi-Fi chip as well, and it works smooth. We don't feel any kind of lag. Even the code is uploaded into the Renesas chip, and later the Renesas chip is communicating with the ESP chip, but still we don't feel any lag. It works smoothly. And here in the R4 Wi-Fi board, there is one more unique thing, which is the LED matrix. So let's test out how we can use the LED matrix, and let's see first of all what's the example code that they have provided here. So here, if we go inside the example in the LED matrix, we have couple of example codes already provided, and the one which we saw at the very beginning, which is already pre-programmed in the R4 Wi-Fi, is nothing but this matrix intro code. So you can re-upload it whenever you want. So here for testing, I'll just open the first example code, which is display single frame, and this example code will display different kind of icons on the LED matrix. And here in the frames.h, they have provided the hexadecimal values of whatever icons or emojis to be printed. Okay, so let's try to hit the upload button and let's see how it looks on the LED matrix. And yes, the code is uploaded, and here on the LED matrix we can see different icons and emojis playing one by one. And now here, if you think how we can create our own icons on the LED matrix, well then Arduino got a really great user interface for you, in which we can design our own icon and can get the code or the hexadecimal values of that particular icon. Let me show you its demo. So first of all, what we'll do, we'll upload an example code called as a live preview into our R4 Wi-Fi board. I'll just hit the upload button and you'll come to know why we uploaded this sketch just in a while. Now after you upload it, you just need to copy this URL and open it up into your Google Chrome. Make sure you open it up in Google Chrome only, because this will work in Chrome only. Press enter and it will open up this interface. First of all, click on this icon and click on I have uploaded the sketch. Click on try and just click here and connect your Arduino UNO R4 Wi-Fi board. And now your board is connected, and now if I draw anything here, in real time it will be reflected on the LED matrix on our Arduino UNO R4 Wi-Fi board. And with this I can easily create any letter, any character or any icon by just drawing that in this particular user interface. Really cool, right? And what's more cool here is, once you create your icon, your character, you can just click on this icon and click on OK, and it will download the hexadecimal values of that particular icon, which you can provide into your Arduino sketch and can use it in your code. And there's one more very interesting thing, which is animation. So you can not only create a static image or static icon, rather you can animate it as well, frame by frame. Let me show you how we can do that. So first of all, I'll clear it, and now let's try to create an animation. So I'll first create a dot here, then I'll click on the plus icon, create 2 dots, click on plus icon once again, 3 dots.
A few minutes later.
So here, after creating all the frames, my animation is ready, and if I click on the play button, you will come to know what kind of animation I made. So as you can see, it is making a rectangle and then it is kind of removing that rectangle, and this will go on inside the loop. Okay, so that's the complete animation that I have prepared. And now if I want to export this animation, you just need to click on this icon, give this animation a name if you want. I'll keep it as it is, click on OK, and it will be downloaded into your system. Now let me show you how we can upload this into our Arduino UNO R4 Wi-Fi board. For that, open up Arduino IDE, and here in the files examples into the LED matrix, you have to open the example called as play animation. Now inside this play animation, we need to change this animation.h header file, and we need to replace it with the animation file that we have downloaded. So I'll copy everything that we have downloaded, go back to the Arduino code, into the animation.h I will paste everything here. That's pretty much it. Now I'll select the right board and COM port, and I'll straight away hit the upload button. Okay, so the code is uploaded, and on the board we can see the exact same animation that we have designed, and that's how you can create any of the icon, animation, anything on this LED matrix with the help of that graphical user interface from the Arduino itself, and later you can upload it into this board and make your project more interesting. So that was all about getting started with all new made in India Arduino boards, and now these boards are available for sale exclusively in India, and the price starts from just rupees 869, which I think is a really good price. And come on, like at 500 to 600 we are getting the UNO R3 clone version, while by paying a little extra you are getting much better and faster board with new features, and most importantly the genuine board from Arduino itself. So that's a really good deal, and I'm pretty much sure this UNO R4 Minima board will going to be the first ever genuine Arduino board of most of my viewers. So yeah, now share your genuine thoughts about all new made in India Arduino boards and the thought behind Arduino moving into India. Well, let's have a fruitful and productive conversation in the comment section. And yes, don't forget to subscribe our channel to see more such content based on Arduino boards. And yeah, that being said, I'm just ending this video here, and now just wait for my next video. Until then, explore, learn, share with me, techiesms.